Alright, everybody, welcome back to another update. This is today's update. We have an enhanced risk in the region here over Texas and Oklahoma, and this is going to be really interesting because yesterday there was a 5% tornado risk outbreak. Well, at least for the potential of severe weather and a tornado potential, but there was not much that happened. But today we have a more significant outbreak. I will do a little bit of analysis, like a mini short sort of video on that event yesterday, more so on the idea of shear funnels that exist from tornadoes, because there was a very interesting shear funnel that occurred near Quanah, Texas, I believe, and it was a really unique phenomena. So with that, I hope to cover that in the future. But today, more significant threat has been upgraded from a slight risk to enhanced risk, with expanded marginal risk now as well. But again, near the Red River, near North Texas and southern to central Oklahoma, near Oklahoma City, and we have 10% non-hatched at the moment tornado risk, mainly due to uncertainty, but there could be a potential for strong tornadoes as well, despite the hatched. And we have 30% unhatched wind risk, so there is definitely significant wind gusts and hail. And so this was what the SPC is having to say today. A pronounced upper trough with an attendant 80 to 100 knot mid-level jet will eject eastward from the Great Basin and southward across central and southern high plains tonight. Large-scale ascent associated with the system overspreads high plains. Lee cyclogenesis will occur over eastern Colorado. The surf slope should deepen further late tonight to early Tuesday morning as it develops into western Kansas. Pacific cold front sweeps east-southeastwards over the southern high plains through the end of the period. Low level moisture, talking 50 to 60s low to mid dew points, and we have over southern and central Texas. We will see some of this. We will see this dew point spread over and ahead of the cold front, and we will see some cap that will exist, and that robust cap will allow for some surface-based thunderstorm development should that cap break eventually. And we're talking about the same thing here. We're talking about a transition of a linear to QLCS mode, which will be very interesting, about the storm mode that's going to be observed. But then we also have some sort of instability concerns and the NAM biases with consistent runs, and largely is currently considered a heavily damaging wind vent because these gusts up to 60 to 80 miles per hour at least within severe thunderstorms, so there will be considerable to destructive severe thunderstorm warnings. Right, more so to see here. So this is going to be a very nocturnal type event potentially. So it's going to be very high risk, not necessarily as a SPC outlook, but like a high risk to the individuals that will come into the path, that will face the path of these storm tracks that will occur. And the lateness is suggesting around 4Z on the HRRR for the initiation of convection along western Oklahoma, along some sort of pseudo dryline type setup. And we can see slightly here with a bit of a temperature gradient and wind shift across this area where it will be located, straight across this west and western Oklahoma and going southwards into western Texas. And this will be the region up here in western Oklahoma, which will be the most considerable spot for this, where these storms will initiate and propagate eastwards. And then we have the pattern here. So just looking back and playing it through the loop slightly, you can see that this sort of pressure tongue here with these different isobars and this central line here is basically where the surface low is located. The surface low is in relatively close proximity, so we would see somewhat of a cold core, not necessarily completely, but like yesterday we definitely saw a cold core type setup. Today it's going to be slightly different, but we have a surface low close to the region, and that could allow for that strong low-level jet to eject directly over and have increased speed shear with with the rate of that maturing trough occurring right when the low-level jet normally ramps up overnight into this region, and so that timing will allow for significant low-level shear, and we will see likely holographs largely extended. For the dew points, currently we're looking at a modest, as this is 1 hour behind, it could be slightly greater with more back surface flow, and this is just a projection from the NAM of what could happen, but it could be greater than this. But we see 60 dew point, like the dew point tongue right here, going upwards into the western extent. So the storms on the southern side will have access to better moisture as of this demonstration, and it will, and then they will eventually, as the system moves west east, you will see the dew points improve and scatter and move along with the storms that will propagate. So that will allow for those storms to maintain for over a period of time. And should the ones in the northward extent get caught into the lower dew points, they will still have access to the rich shear, upper level shear and mid shear that will provide for the rotating thunderstorms still, even into nocturnal period in 06Z. I tend to like to take soundings in this region, get a better description of what is going on. So I'm going to pursue one south of the Red River Valley, and we have the first one in the more northward extent. As demonstrated with the enhanced low-level jet, we have a significant curving and veering of this hodograph, with strengthening winds going from 10 knots to within 850 millibars, upwards of 50 plus knots, nearly 60 knots as well. So we could see this very rapid speed shear just above the surface, really, in relative terms. And we have that veering that occurs over the 1000 to 850 millibars, and particularly up to the 700 millibars from the southerly to westerly, more southwesterly direction. And then we see here as well, with this sort of curvature in the upper levels and the 0 to 3 kilometer region, and then we see some backing in this region with some decent outflow, and we see it coming back a little bit, the blue line back towards the where if you were to overlay the supercell around this hodograph, you would kind of expect to see some good ventilation with the supercell overall large scale, and we see around 30 knots in the storm relative inflow, and that would suggest largely between a regular sized supercell as opposed to mini supercells, which are those described as small beam type. And the area on this curve is since it's lengthy and large hodograph, there will be a lot of area underneath the curve which will represent the storm relative, the SRH, and that is essentially represented here with this effective inflow layer upwards of 531 meters squared per second squared, which is very significant values, what you typically expect. In some sort of setups, like for example in yesterday's setup, you were seeing less than 200 meters squared per second squared. Now we're seeing almost double that, and these will be in almost like a much more primed environment than yesterday's setup. And with this, we also even have effective bulk shear of 55 knots, so plenty of shear for the updrafts to develop. The only thing is when you have these small young updrafts that are developing in such high shear, and potentially those lower modest 58 dew points, they may tend to struggle on the beginning period and the phase on which they initiate. But should those storms also maintain and move along the dry line and propagate along the dry line, that could help in the maintenance and growth of the updrafts. And also if they conglomerate from back building, that will allow for the development of the updrafts much better and the growth of it to become mature supercells. So then that will allow for several mature supercells to develop, and that could be entirely possible. Yesterday we did see one mature supercell that was two, but one very significant one that tried developing but then fell apart quickly after the thermodynamic profile was not as great. We'll still see remnants of this capping inversion, which will be significant though, as we still see inhibition in upwards still of minus 54 in this region, just above the 850 millibars, and this inversion will prevent some of the low level instability as well as some of the mid level instability, which is important, and will also just sap some of the instability that is required for these storms, because it is about the buoyancy of these updrafts and allowing them to push up through that dry level, the dry E level that's going to be persisting within the mid levels. And if they cannot strengthen and develop as through this cap inversion, then they will struggle, and you'll often see that low reflectivity where these updrafts fall apart. And also, should these updrafts develop and become healthy, you will see potentially a well sculptured structure in the mid levels with as a cyclone. Should this dry air wrap around the occlusions of these updrafts, they will become very like a visually aesthetic sort of feature potentially. But despite the sapping, it's not completely, as for previous runs, it was much more of an inversion, but due to the nature of this capping inversion now being torn, or shall I say being reduced from what it was initially, due to those enhanced backflow, some of that initial surface heating during the daytime periods, and the more of that shortwave troughing coming across and propagating eastwards, it should allow for that breakdown slightly. And we see the 3 Cape upwards of 82 joules per kilogram, which is plentiful, rather than moderate, which is going to be less than 50 joules per kilogram typically, if it's to be just in the minimum adequate side. And overall, this is a very favourable profile for what was not necessarily anticipated. And also, one of the things on recently, as mentioned by Cameron Nixon, is when there is an excess of high water, the least water with the highest cape, you tend to see the better updrafts and better growth of the updrafts as well. So with this sort of access to large instability but less of that saturation within these levels of the mid levels and these lower levels of the atmosphere, it will help. And then when there is this 850 millibar, when you see the heights raise up to 850 millibars for the dew points and the thermal line, that shows that this is at least going to have an updraft that's able to push through the mid levels relatively well, with decent access to moisture, as depicted with 60 dew points, and that allows for the steeper lapse rates in the lower levels to allow for that buoyancy of those updrafts. And we see a PDS tornado sounding, not necessarily like absolutely suggestive that this will come into fruition, but it's mainly due to the elevated instability values represented in this, which is going to be just slightly southward of the previous sounding in the same time period. But we have 2075 joules per kilogram depicted on this in a mixed layer cape for this sounding, and that would suggest that the healthiest updrafts could potentially occur within this part of central western Oklahoma, and just going to be near often in this magic corridor in the southwestern to central western Oklahoma, where there is in these very lesser populated areas very unique superstars that tend to develop. We saw it last year with Hollister and with Duke, Oklahoma. And with this setup, we also see rich moisture within up to 850 millimars, allowing for those air parcels to rise efficiently and allowing for the growth of the updrafts, allowing for those strengthening updrafts much more likely. And should those updrafts then develop with this sort of profile, we could see the ecotops bloom within 10k feet, so all the way up to 30, 40, 50,000 feet very quickly, with at least adequate 62 dew point moisture. They could even get greater than that. And we do see relatively low LCLs within this as well. So these cloud bases will be relatively shallow, and that should potentially indicate for those low level mesocyclones to develop and potentially allow for like any sort of condensation to reach closer to the ground, so that the tilting and stretching of vorticity will it's much a higher probability for that to occur to the surface, and this sounding is most demonstrative of it. The last part is the southern extent all the way to the Red River Valley, and should this also be the case, we see a little bit of what could potentially be saturation due to this upper level cirrus cloud cover, which could be sapping the instability in the upper levels, and that will partially affect the ability for the updraft to develop, especially in the mid levels, and could affect the overall instability, and so therefore the buoyancy of the updraft as it grows within that part of the atmosphere. But also, the one thing to note is the lower level instability values are less, with much more stout inversion, and it is also much more separated V-type inversion, where there's a almost 11 degree dew point spread with higher LCL, so that could be more unfavorable. But yet there still is a much favored kinematic profile in particular, and still modest on the thermodynamic side for the total instability in the mid levels and the upper levels of the atmosphere. And then we have the HRRR, which will also demonstrate here by 4Z the initiation of these storms, and we see a very robust storm on the southern side. But then by 5Z they all tend to dissipate, at least, or don't seem to be as robust on this CAM run, and this by 6Z, 7Z persists, and then this can be part of the next day outbreak, really, when these storms continue. So it will be something to watch. And as of yet, there is still a question about the significance of tomorrow's event, which will be in discussion for tomorrow, on that day one risk when I normally do the updates. And it'll be really interesting because it does not seem necessarily as significant. And I do believe potentially the day after along the east coast could be more significant. And as provided with analogues, we have seen that for around the 20th, if I'm correct with my dates, I believe somewhere around the 23rd to 27th, between there in 2016 February, there was an outbreak along the east coast, which was a robust outbreak that produced several strong EF3 equivalent tornadoes, which was demonstrated for the prime environment. And the soundings that we have for that east coast around Wednesday is almost very similar to that of 2016. So it could be very significant if that was to pan out. But the dew points, the moisture returns will be the most questionable part to whether that will actually come into fruition. But in particular, coming back to here with everything that's been mentioned, we'll see that linear transition occur overnight within the central Oklahoma and along central Texas, but we'll still see some of these robust updrafts on the southern side. But then this could be necessarily not necessarily proving to show what actually could have occurred, because within 1 hour it's demonstrating a linear convection with some of these lesser robust updrafts, and that may not necessarily be true should the dew points and even the real estate expand as the time progresses with a strengthening low-level cyclone in that central to western Kansas region. Okay, with this, I think this will be a relatively shorter update. I don't have too much to say. It's a little bit late for me, so I don't have as many. I'm not thinking with as much creativity and thought in mind. But I will see you guys in tomorrow's update, and I will do any post-analysis updates on the YouTube short section about any events that occur with this. And previously, I have done with some of the February and January tornado outbreaks that we have occurred already. I've done that, so you can check those ones out as well. With this, I will see you guys in the next update.